Hello, everyone, and welcome back to another show of Dojo Live here this Tuesday, October 11th, 2022. My name is Kim Landis, and it's my pleasure to be hosting along with America Guerrero today.
My
Hello, America.
pleasure. Hi.
Hey, and of course, the most important person of today's show is our guest, Steve Van Lare, who is the VP of Engineering at Anjuna Security. Steve, thank you so much for joining us today.
Oh, thank you so much for having me. Pleasure to be
Yes.
here, Kim, in America.
Yes, we had quite a lively conversation here backstage pre-show, and I think it's going to be a good talk. We really look forward to learning from you and learning your story and all about cloud security and confidential computing and what that means. But before we get into that topic of conversation more in depth, we'd love to learn a bit more about you, Steve. Just your story, your background, what's kind of led up to your Anjuna days. Please share.
Thank you. Yes, I'm been in Silicon Valley my entire career. I moved up to Santa Clara to go to university in the early 80s. And I was trained as a hardware engineer and spent the first decade of my career building large ML systems for the government. And so at the time, you couldn't really do machine learning or AI in software. It was just too slow. So we were doing it in hardware. And so that's how I started my career. But I really wanted to get out of defense contracting after about 10 years in the space and really wanted to transition over to software. As in the early 90s, software is beginning to be a bigger thing than hardware is, and was having a difficult time finding a company that was willing to take a risk on a defense contractor. I usually got the reply, we don't need somebody who can design a $600 toilet seat. We need somebody who can, build whatever. And so I was going through that process, and a friend of mine called me up and he's like, "Hey, Steve, I'm starting up a company." And I didn't even ask him what the company was about. I just asked him, "John,
Yes.
is this hardware or software?" And he said, "Software." And I said, "Great, I'm in. I'll be a founder with you and start the business." And that was the first startup that I worked on that ended up on a 15-year run as we got bought by a company called Agile Software, got bought by Oracle, where I ran a group in the application space for that. And I found I just didn't like the big companies all that much. I didn't like Boeing all that much. I didn't like Oracle. We were doing some really neat things, but I really liked the ability, if you didn't like something, you can just change it, that you get in a startup. So I went back to the startup world, went to a security company called 41st Parameter, where I spent another 5 years, and we built out fraud prevention solutions. And I started getting back into the AI part of my background. We eventually got bought by Experian, and I repeated the process again and went to a couple of more startups before I ended up at Anjuna. And all of those, I was kind of pushing towards AI and ML because I wanted to get back to that part of my education. But Anjuna is decidedly not that kind of company. But the technology really attracted me. The idea really attracted me. And so I took that on about 2.5 years ago, 3 years ago at this point, and have been having an awful lot of fun with it ever since.
So I do want to get, later on into the show, I'd love to learn more about your personal journey and the decision-making that led up to, switching focus in your careers, like you just mentioned, going from AI to machine learning to the security sector and, what that meant. But before we get into that, let's talk about Anjuna Security and what it is that you as a company do, the problem that you're solving.
So Anjuna Security makes confidential compute easy to take on. So around 2015 or so, the chip manufacturers, you can even go back further than that. So Apple started putting these things called trusted execution environments, or enclaves, into the phones to store your biometrics. And there was the case when, the FBI goes knocking on the door of Apple and they're like, sorry, we can't give you the passwords. And ultimately, that's protected inside a trusted execution environment. Intel got into the game in 2015. AMD followed suit, and all the chip manufacturers have been adding this ability to do confidential compute into their CPUs. And one of our founders was getting his PhD at Stanford in security in Dan Bonet's group, actually. And they ran across the SGX technology in Intel's chips. And Intel was, I think, fairly convinced that everybody was going to go, this is so stinking cool. Everybody's going to hire a bunch of assembly language programmers and rewrite all their programs to take care of the really precious bits of it and put them into enclaves. And Jan's idea was not that. Jan's idea was, how do you run complete applications inside a secure environment? Today, we kind of think about securing the machine as opposed to securing an application. And quite frankly, I don't care if the cloud vendor gets hacked. What I care about is if my data gets hacked.
Right.
And if they're on a machine, it's kind of one thing. But if you can separate them into two different things, you can protect the data differently than you protect the machine. So that was the idea of the business. We've got encryption at rest. We've got encryption in motion, but we don't have encryption at use when your programs are running. What stops another program from being able to access your program's memory and get the data out of it? And so when the recruiters approached me with this, I was like, that's pretty big. That's a pretty transformational thing. And I didn't know anything about SGX or TEEs at the time. And it's like, okay, if they can really do this, we're changing computer architecture. And how often in your career do you get a chance to fundamentally shift the architecture of the way a computer works? It doesn't roll along all that often. So I looked at the company and said, well, it's early and we don't really know if the clouds in the market are going to adopt this yet. But if they do, it's going to be pretty transformative. And I'd love to be part of that journey. So that's where Anjuna gets started. Anjuna takes all that really complicated stuff that you need to do to be able to support the enclave, and we make that simple so that you can just say, run Anjuna, and then put my program inside of Anjuna.
Beautiful, beautiful. And I think what's really inspiring about this is just how sometimes it's just a change of perspective or a change of angles and looking at something different. And it's like, aha, that makes sense. And it's fantastic when that happens. It reminds me of a show several months ago where it was this idea of looking at a building as an organism. Like a perspective that simple can shift the way in which you approach things and problem solve. And I think that's Anjuna here as an example of that as well. So let's talk about the topic that you specifically chose today, which is
confidential computing, making the cloud safe for sensitive data. How can confidential computing address the unique cybersecurity challenges of today's tech? So please, Steve, tell us, why did you choose this topic for today's show?
Absolutely. So confidential compute is the overarching name of what the trusted execution environments and the chips is called. And there's a number of companies that are working on confidential compute. And why I think it's so important for the cloud ultimately comes back to what I said earlier. I don't really care if the cloud is hacked. I care if my data is hacked. So how do I draw the perimeter, not around the physical items, the computer, the cage, the network, but around the logical element of my application and put that in place. So it's that reframing of the notion that there's this extra layer. There's a joke in computer science that says there's no problem you can't solve by adding an additional layer of indirection. This is that new level of indirection on the security front. And since it's built into the hardware, you don't have the performance impact that you might get from some other ways you might solve this problem. And so around 2020, the chip vendors started supporting this in 2015. Around 2020, the clouds started announcing support for it. So Microsoft was first and rolled out their confidential compute capabilities. We had Google second. We had IBM in there. We had Amazon rolling out Nitro enclaves. So all of the clouds started supporting this in 2020. And so ultimately, there are a lot of workloads that are too sensitive to run in the cloud, because if somebody can get to the infrastructure, they can get to everything on the infrastructure in a machine today. But with confidential compute, you get to prevent that. You get to stop that motion. So we've seen a lot of interest from banks, from governments, from healthcare, from the Web3 companies that are saying along the lines of, I want to run this stuff on-prem. I want to run it in the cloud because I want the cost advantages of running it in the cloud. But I'm really worried about the circle of trust. I'm worried about who else is got access to my machines, who else has access to this capability. And so the ability to fork out a space of memory logically and say, this is going to be protected not by the CSP, it's going to be protected by the hardware that's in the chip. That gives us a new capability we've never had before. And so an awful lot of motion then towards the cloud in these various industries.
And how common is to provide this confidential computing to startups?
Sorry, what was that?
How common is to provide your services to startups? Because you're mentioning banks, like big companies.
Yes. So obviously banks and governments, their cycle of adopting things takes years. So where we're seeing the faster adoption is in the startups, which is part of the reason I like working at startups. If you see something and you like it, you say, yep, let's go do it. And so we are seeing startups that are able to adopt this. And in their case, they look at it and they go, that's really interesting. Never thought about that problem. I had a CEO ask us the question. He said, okay, how do the big companies keep their employees from seeing customer data? And today, that's not really a problem you can solve. But with confidential compute, that is a problem you can solve. You can stand up some compute, you can put it in a confidential environment, and then the customer data goes into it. And your employees can't peer in that box.
So what this makes me think of, I'm always an analogy person. If you watch the shows, I'm always like trying to figure out ways to wrap my head around what the guests are saying and to put it into something a bit more tangible, a bit more physical. And the image that's coming up to mind, and laugh if I'm wrong or correct me if I'm wrong, but maybe we're all familiar with the Guardians of the Galaxy first one. And at the end, right, like all of this, I don't know what planet it is, but all of the individual ships kind of have their own little shield. And then they come together and make this like giant shield. So that's kind of what I'm visualizing here. And each one of those ships is data of some sort that's protected individually, and yet it's all protected together as well. Is that what you're talking about? Am I off
So
base
I think
here?
that's an interesting analogy, and I like it because if you think of each ship as a node in your compute, right? So I haven't built in the last 20 years, I haven't built an application that runs on a single computer. All my applications run on multiple machines, right? When you put something in the cloud, you're typically designing it so it can scale horizontally. And if I have more users, I just spin up more nodes and everything works. And the challenge with a lot of technology is, since the protection is fundamentally machine, what have I put on this machine? What have I put on that machine? What have I put on the next machine? You have to come up with other ways to protect, right? You've got defense in depth, where you just add layers and layers and layers of band-aids to try to protect things. But if I can run a job in memory and I know that nobody can get into that box, I can create a private public key pair for encrypting data. And I can share that with another box that's running on another machine the same way. And then the two of them can communicate with a set of keys that nobody has. Even the people that are running the machines don't have access to those keys. So as you think about all those stars linking up and building that shield, if you think of it as individual computers, each one is protecting the data while the data is on that machine. But how do you detect it in the complete application? How do you detect it everywhere that data happens to go? I'm working on a solution at the moment with someone where, when you take your credit card and you stick your credit card in a point of sale machine, the reason for the chip is there's actually a little confidential compute chip there, and your credit card number is encrypted from that point of sale all the way to when it gets processed. And the vendor doesn't have it. They don't store it. They don't see it, which is a good thing. When you do e-commerce, it's not the same. Your credit card, you type it into the browser and it goes to somebody's Nginx server on the website. And if you can get access to the memory of that machine, you can pull out the credit card and do what you want to do. So what we want to be able to do is use confidential compute so that you can encrypt it with a key that's provided to the browser and leave it in an encrypted state all the way until it gets to the processor at that last step. And that's not something you can do with traditional compute today, but confidential compute gives you this ability to isolate these workloads and then do these kind of things.
Yeah. And in terms of, that's kind of where we're at and the challenges that we're facing, where do you see this headed in the future? And what is the rollout going to look like? How much time is it going to take? What are your predictions?
So the next couple of years, I think, are all about enablement, is people that are building applications beginning to incorporate this technology into their tech stacks and into their applications. And a lot of the Web3, the wallet companies that are doing crypto coins, right? They'll advertise they're using confidential compute to help protect your hot wallet and do that, right? They're using it as a competitive advantage at this point, but it will become table stakes as all of the wallet companies adopt it. And we'll start seeing lots of applications. Whenever a security technology becomes easy to use, and it doesn't have a performance impact, you kind of turn it on everywhere. You say, why not, right? CNN has HTTPS, right? They encrypt your connection to CNN. I'm getting news. I'm not providing PII. I'm not doing any confidential processing with CNN, but they want the little lock, and why not turn it on, right? It's easy. It doesn't cost you anything to do it. 10 years ago, you might have had to buy TLS encryption cards, and you might have been putting things in machines to get that to work. But today it's ubiquitous. And so we'll go from this phase of the technology being adopted by companies that are trying to do something they can't do, like move an application to the cloud in the case of a bank, or trying to secure wallets or credit card transactions. But you'll start seeing use cases where you can protect your data and know that your data is protected wherever it goes in ways that's not possible today. So that, as you get down the road, 3 years, 5 years, 7 years somewhere, is where I think this ultimately starts to go. And then you start annotating data and applications, so you can say, I'm only allowing this kind of data in this processor, or I only want my data to be handled in these kind of situations. We have a way to enforce that now.
Beautiful, beautiful. And in terms of, not affecting production and this increasing massive numbers, right? Data and just duplicated and replicated. And, I've got data everywhere, like, honestly, that I'm probably not even aware of that I have in places anymore. We all have accounts that we opened somewhere, only used once, forget about them, and etc. So as this just continues to explode, what are some of the solutions to not affecting production and, keeping things as close to real time? And how are we going to do that?
Well, and that's, the mission I'm on ultimately is to make sure that this is easy.
So the CTO gets to do the dreaming and you get to do the doing, and you're like,
yeah,
thanks.
well, yeah, Jan is fantastic, and he was doing a lot of the doing when I joined the business, and I'm always happy to have him in the labs with us in working on things. But yes, that's there's always vision, and then there's the reality of where you are against the vision. And so it's important to make sure that we know where the gaps are and what are the work we're doing to close up those gaps. And this has been true with any startup I've been at, is, you've got this idea, and then you're walking down the path to get to that idea and fulfill it and bring it to all its promise. I mean, one huge step for us was when the clouds adopted this. And as all the clouds adopted it, it really enabled us to go to a lot of different places, as opposed to only being focused on what servers do you have in your own rack, and have you bought the right servers with the right capabilities, right? So that opened up an awful lot of what we need to do. There's still more work to do. I mean, we're very proud of the fact that you can get up and running, in hours or days and move an application over. But there's new challenges that it imposes, right? If I've got an application and it's running in a secure environment and nobody can get into that environment, that means the debugging tools you have can't get into that environment as well. So what rules do you want to enable debug? Because every hole you punch in the perimeter is a place that an attacker can get through potentially. And so which ones do you want to permit? Which ones do you not want to permit? So by default, we're closed, and then you open these things up.
That makes a lot of sense, right? Yeah, and a kind of an as needed basis, but in real time,
Yep.
which is insane to think about happening. I wanted to come back as we're talking about the creativity and, the switch and the relationship you have with your team and your leadership. Let's talk about your personal journey a little bit before we move on to the culture side of the company. And that was your journey of shifting from, an AI kind of machine learning focus to a security focus and this approach. What was it like for you and your decision making of, yes, this is the move that I want to make? Perhaps your process of, for me personally, I think of like, gosh, you're honored and you're like, this sounds exciting and this is something I want to do, but I'm afraid. Like, what do they see in me that I don't see in myself? Am I going to fail at this? Am I an imposter at this? Like, what was your story? If you could share a bit of that and your lessons learned from your transition.
Well, I think I can explain it a little bit. Some of the coaching I give to managers who work for me when you're hiring someone is if you're looking for 10 things, why, if somebody checks off all 10 boxes, would they want to work for you? Engineers like to learn things. They like to do new things. They like to expand. They like to grow. I'm no different in that regard. Even though I don't get to code at work anymore, that just means I do things in my garage and build things at home. But when you look at that list, I always want to know, why is somebody joining the business? Why are they excited to be here? And why are they, what motivates them and what gets them excited? In my case, I've been leading engineering teams since the early 90s, maybe even late 80s when I first started managing. And I had that part of it down. I've helped scale companies up from kitchen table all the way to thousands of employees. So I knew I could help Anjuna in that regard. Cryptography has always been something I've been fascinated with. I'm a bit of a math geek, but I've never got to spend a lot of time with it and thinking about it. And so for me, that was where's my growth area? What am I excited about doing here? And so I've got a lot of things to learn from the cryptography side, which has been a lot of fun. But also, as I said, this is new greenfield stuff. This security environment hasn't existed in the past. So the ability to bring it forward and help make that market, quite frankly, I spend more time out talking about this than I ever have in any of my previous jobs. And that's been fun as well. So I look for that in the people I hire. What are they looking to grow as they join the business? What gets them excited about this opportunity? And I've done that for myself as I've walked through my career. I talked about I wanted to move to software. And so honestly, when I took that job with my friend, I thought it was going to be a 6-month job. I'd have software on my resume and I'd go off and do other things at that point. And it took a different path, but I knew I was looking to what kind of change I was looking to make. And it was close, and we run with that one. And as I said, I'd been moving my career back to the AI spot so I could get back to some of the math that I grew up with, quite frankly, and wanted to get back into the fun of it. And this showed up, and it struck me as a large enough challenge that I'd be excited and would have a lot of fun working on it for a number of years. So I made the call to get involved.
I love it. That's my takeaway for today, a large enough challenge, not only for you as an individual and the role that you stepped into, but obviously Anjuna and the problem that you are solving, which is fantastic. So I think you already touched on this quite a bit, but we've got a question, America.
Yeah, now that you touch about why someone would like to join Anjuna's teams, there was something that I read on your website from one of your employees that says, as a member of several women in tech organizations, it is important for me to align with a company that cares about diversity and inclusion. So why this is important for Anjuna? How is the culture? Are there other values? What can you share?
So great question. And it was part of what I was looking for. I've worked in a number of different startups and different environments. At this point, I certainly know the ones I like and the ones I don't like. So the other founder, Eyal, who is the CEO, a lot of my time with him before joining was about this very question. What is the culture that he wants in the business? And what are we trying to build? And he and I share a lot of similar thoughts on this, but I'm very much of the belief that I want the environment I work in to reflect the community I live in. And the community I live in is about 50% women. So it'd be nice to have 50% women in the business. We don't. I did a talk at a previous company on women in tech. And I was shocked to learn that when I graduated college, it was about 33% women graduating there in the late 80s were graduating with technical degrees. And when I did this presentation, they gave me the data on it, and we're now closer to 13% or 18% women in tech. And I'm thinking, how did I miss the fact that this was going down as a number overall? And so it is important to say, how do you get more people involved? And it's not just women, it's also the races you get involved, the backgrounds, the cultures. The more points of view you can bring to a problem, the more creativity you can bring to a solution. And I think that's really, really important.
Yeah, what you're saying actually makes me think of the I'm all about movies today. I watch too much TV. The film Hidden Figures, right, which tells the story of the women, specifically the women of color, who helped get us to the moon with NASA. And I think that's a reflection. Honestly, that's like the birth, really active time in the history of computer science. And it was a majority of women and a majority of colored women, I think, that even made it happen. And that, like you're saying, that shift, that the statistic is actually quite sad, 33% to 13%. And I think even before the 80s, 90s, it was probably even more women. I don't know why that is. I don't know why that has happened.
It is depressing, and I don't know why it's dropped, but you go all the way back to the start of computers, and you've got Ada and Babbage working on the difference engine together, right? There's two people, and you've got a 50% ratio at that point in time. You've got Grace Hopper later, kind of the inventor of the word bug, working for the U.S. military. One of my personal favorite stories is Bertha Benz. We all think of, Mercedes-Benz, and I don't even know his first name, but the inventor of the car there. But he was just kind of goofing around in the backyard. It was her money. She was the drive. She was like, look, you can't play with this thing forever. We have to go sell it. She's the one that got it out there and did the marketing and pushed it and drove it and really made it happen in the marketplace. So it's really important. And as a company, you have to, you get the people that you hire as you interview folks, but you need to work hard to try to bring in a diverse group of folks.
Yeah. And I think too, thinking about it, go to your point about just, graduation rates and things, it needs to start much earlier than that. You can only bring in the diversity from the pool of individuals that exists, right? And if it's not a diverse pool, at some point you're going to be quite limited in your capability of
That's right.
of who to bring on board. And so I think all of us, myself included, especially as a mother of two girls, I need to start encouraging them and realizing that they're just as capable, and getting them interested. Is there any, I know we're a bit off topic here, but in the final minute, how can we do that? What's your experience been? Or you, as someone in STEM, or potentially a father, I don't know, how can we encourage this the pool to grow, not just the hiring?
Yeah, I mean, in software development and hardware, you're always thinking about how do you shift left and move earlier in the schedule. And I think ultimately that's where some of this needs to continue pushing. The robotics programs, First Robotics, et cetera, they're outstanding. Getting more people engaged, I think, in some of those is a tremendous feeder to getting people hooked and then jumping into the industry.
For sure, for sure. Well, thank you so much, Steve. We're at the final, the end of our show today. If you could believe it or not, a half hour goes by quick. It's been so much fun learning from you, your story, your involvement. I think your courage and being able to pivot and switch directions. And of course, that speaks highly of Anjuna as well. And just recognizing something, flipping, a different perspective, and then having the courage to kind of make that happen. Thank you so much for joining us today.
My pleasure. It's been great talking to you both.
Yes. Stick around for just 1 minute as we go off air. But before we do, we'd like to introduce what's coming up for the rest of the week. America?
Yes, tomorrow we're going to have an interview with a woman, with Manuela Sonnenschein. We will find out tomorrow her last name.
I think it's Sonnenschein. We'll see.
Sonnenschein, yeah. She is the CEO and founder at Kedea. And the topic is going to be about closing the loop on single-use packaged beverages. How can beverage companies deliver product people known and love without throwaway packaging? Tomorrow at 10 a.m. Pacific.
That's right. And we also have a show coming up on Thursday. And on Friday, you'll catch us for another People Matters panel. This time we're talking about creating an awesome work environment. And we'll be joined by 3 women as well. So don't miss that one. Again, thank you so much, Steve. Have a great rest of your day, everyone.
All right. Thank you.